Write down heading effect of temperature on resistivity. Okay. So see guys, suppose I have a conductor. And let's say this conductor is at temperature T1. Okay. So when it is at temperature T1, do you know? Remember this electron? It was moving in a zigzag path. It was going like this. But can you see? Ultimately, it was drifting towards the left, the direction. Do you remember this case, guys? Do you remember this thing? Initially, the free electrons are in random Brownian motion. They move in a zigzag path. So if you apply a potential difference, then what happens? The free electron, they have a tendency to move towards the end of higher potential over here. You remember, if the electric field is set up over here, this end is A, this end is B, this is A, this is VB, then VA should be greater than VB, right? This have already we discussed. So VA minus VB is basically the potential difference. So what happens? An electric field is set up from higher potential to a lower potential, due to which the electron moves in this direction, right? Yes or no?
Yes, sir.
Now what happens when I decrease the temperature? Suppose the same thing, but when I decrease the temperature, now see what happens. Let's say this is at temperature T2. So when this is at temperature T2, can I say this particular thing that the zigzag motion will decrease a little bit? If I have a temperature T2 which is less than T, can you see on decreasing the temperature, or basically when temperature decreases, then what will happen? The randomness of the free electrons, other free electrons, with which this electron was colliding with, right? Randomness of other free electrons will decrease. Yes or no? Yes or no? Initially, what
Yes.
was happening?
Yes, sir.
Where the other electrons were in random motion, right? Also along with this electron, but we are trying to study the motion of this electron. So what happens when temperature decreases? All the other electrons motion, they will what? They will decrease relative to this electron, right? Due to which what will happen? The number of collisions, it will undergo, will decrease. Yes or no? Yes or no? I am. Suppose if you decrease the temperature further, if you decrease the temperature further, then will the electron be moving like this? Yes or no? Can you see this thing? The randomness is decreasing as temperature is decreasing. Is this clear? So basically, always remember, when temperature decreases, randomness of other free electron will decrease. That implies the number of collisions it will undergo will decrease. That implies its mobility, the mobility of the electron, mobility of the free electron increases. If mobility increases, that implies the conductivity increases. You remember? Sigma is basically Ne into mu. Do you remember this formula, guys? Guys, everyone remember this formula we discussed in drift velocity? Shall I
Yes, sir.
tell you where? I is equals to NEVD. VD को you write
Yeah.
Ne into mu into D. And then this J is equals to this thing, sigma, oh sorry. So sigma into E, and this is 1 by rho. Do you remember? Yes or no? So the same thing. So if the mobility of the free electron will increase, what will happen? The sigma will increase, and that implies rho. So write down this whole flow chart. Temperature decreases, randomness decreases, number of free electrons decreases, mobility increases, and sigma increases. Hence, the rho decreases. Is this clear? Whenever you're done, you're noting this. System.
I'm copying still.
Yeah, that's what. Copy, copy. So did you understand the logic of when increasing temperature, resistivity is decreasing? Guys, logic समझ में आया?
Yes, sir. Sir, done.
Done. Everyone done? Everyone done?
Yes, sir.
Okay.
Yes, sir.
अच्छा, tell me this thing. So ultimately the final result is कि when for metallic conductors when temperature increases.
So are you saying something?
Yes, I am saying something. आवाज नहीं आ
Because
रही
I
क्या?
can't hear you.
Can you hear me now? Hello, hello. Can you hear me now? Hello.
I'll leave and join.
Yeah, sure,
I
sure.
can't hear you.
Is everyone else able to hear me?
Yes, sir.
So for metallic conductors, when temperature increases, resistivity decreases. And the reason for this is the whole flow chart for the reason. है ना? Any doubt, guys?
So,
Tell me.
so with increase in temperature, resistivity decreases
Yes. But
because you have taken like
एक second.
temperature
Sorry,
decreases here.
sorry, my bad. My bad, bro. My bad. Now is it fine, bro?
Yes, sir.
Okay. चलो. So for metallic conductors, when temperature decreases, resistivity also decreases. है ना?
Decreases.
So please remember, if I increase the temperature, resistivity will also increase, right? है ना? Yes or no?
Yes, sir.
Acha. Tell me
Yeah.
this particular thing, guys. What will happen at temperature 0 Kelvin? At absolute zero, what will happen? At absolute zero, do you know remember what happens at absolute zero? All the molecular motion
Stops, right?
stops. If all the molecular motion stops, that implies now. Tell me this particular thing. If all the molecular motion will stop, then this electron will it collide with any other electron if it's not in the path?
No.
So basically, if I assume that other electrons are not in the path of this electron, then this electron will move in a straight line, right? Without any collision, without any zigzag path, right? It will move in a straight line, right? Why was this
Yes.
collision? Why was the electron changing its path? Because the collision with other electrons. But now the other electrons are not moving, so hence it clears. We assume that it clears a straight pathway for this particular. If this happens, then that implies mobility becomes very high. If mobility becomes very high, that implies the conductivity becomes very high. If the conductivity becomes very high, then this type of material is basically called as a superconductor. So any metal, if you decrease the temperature of that metal to absolute zero, then what will happen? That conductor will start behaving as a superconductor.
Superconductor.
Resistivity will be approximately zero. Is this
Zero.
clear?
Yes, sir.
Although conductors already have a very lesser, very less value of resistivity, but if you decrease the temperature to zero Kelvin, then even the small amount of resistivity which has, even if not loses that. Okay, is this clear, guys? Acha, by the way, if mobility decreases, what will happen to the drift velocity? Did you change the electric field?
No.
No. If you didn't change the electric field, can you see from here? You can also say this particular thing. Even the drift velocity increases. Right? So you can say this particular thing. Even the drift velocity increases in the mobility. Is it clear?
Yes, sir.
Okay. Now, how is exactly it is related mathematically? So mathematically, suppose if you have a conductor at temperature T equals to T naught, and you change the temperature of the conductor to T equals to T dash. Assume no thermal expansion. If there is no thermal expansion, that implies the, you remember thermal expansion grade 11, everyone?
Yes, sir.
So if there is no thermal expansion, then what will happen? The length will remain same, the area will remain same, everything will remain same, right? If the resistivity over here is rho naught, and if the resistivity over here is rho dash, then the, you know, rho dash minus rho naught upon rho naught, which is, this is basically what? What is this change in the resistivity upon original resistivity? So this is basically delta rho by rho naught. Is this clear, guys? Hello?
Yes, sir.
So delta rho by rho naught is directly proportional to the change in temperature. You remember the same relation was there for the thermal expansion as well. So delta rho by rho naught is equal to, when you remove the sign of proportionality, introduce the constant which is called as alpha r, where alpha r is called as the temperature coefficient of resistivity. Okay, the SI unit for this is per degree Celsius or per centimeter. Is this clear? Is this clear?
Yes, sir.
So delta rho by rho naught is equals to alpha r delta t. And can you see if I can write this thing, rho dash minus rho naught is basically equals to delta rho, which is equals to rho naught alpha r. This is also one of the formula. Can you see, guys, the relative change? This is the relative change in resistivity, 11th grade, first chapter, units and dimension errors. Relative change
Yeah.
in resistivity. This is basically the absolute change in resistivity. And what about the last one? The new resistivity rho dash is equal to, I can move this rho naught to the right hand side, take rho naught common. It will become 1 plus alpha r. Are the formulas seeming similar to thermal expansion?
Yes, sir.
But please remember,
Yeah.
this is not the coefficient of linear expansion. This is the resistivity coefficient. Is this clear? Symbol is same, but numerically and physically both are different. Okay?
Yes,
Please.
sir.
Also, the value of alpha r is positive for metals and mostly other conductors, but alpha r is negative for semiconductors. Is this clear, guys? Is this clear, guys? Alpha, the value
Yes,
of
sir.
alpha r is positive for metal, alpha r is negative for semiconductor. Please note, if this happens, then on increasing temperature, resistivity will also increase for metal, but on decreasing temperature, on increasing temperature over here, in the case of semiconductor, resistivity will decrease. इसके दूसरे रीजंस भी हैं, it has some other reasons as well which we will be discussing in the semiconductor chapter. Okay, guys, once I'm done with current electricity, then I'll take up on the pace gradually. So try to bear with me. I'll try to increase the pace in current electricity. Okay, will not be doing it exactly as slow as
So semiconductors, T is increasing and rho is decreasing, right?
for semiconductor, yes, when temperature increases, resistivity decreases. In every other case, it was directly proportional. When temperature was decreasing, the resistivity was decreasing. And when temperature increases, resistivity also increases. Can you see? Mathematically also. If this is positive, then this whole thing is positive. It is 1 plus something. It is greater than 1. So that's why rho dash is greater than rho naught. Okay? Achha. Try to note this thing. I'll just give it to you.
Can you scroll up for a minute?
Sure. I'll scroll up. और ऊपर ये बस
So it's fine. It's fine. It's fine.
just give me 2 minutes. Hello. Done, people? Note it down. Everyone done?
Yes.
Please write down the next heading: experimental verification of Ohm's law. Write down. Let me just shift. Experimental verification of Ohm's law. We'll start with the circuit analysis today. Now see guys, suppose first of all, in case of Ohm's law verification, what are the devices used? Apparatus required, a rheostat or a variable resistance. You understand what a rheostat or a variable resistance is? Guys, do you understand what a rheostat is?
Yes, sir.
The resistance of this device can be varied by changing the length of that device. Na? A voltmeter is required. A variable battery is required. What is a variable battery? The potential difference or the voltage can be regulated in this thing. Na?
Yes, sir.
An ammeter, some connecting wires, and a switch. Wait. Two minutes. The screen might have gone blank, right?
Yes, sir.
2 minutes. I'm searching something. Experimental verification of Ohm's law images. Guys, can you see the experimental verification of what all devices are used to be here? Can you see an ammeter over here, a voltmeter over here, some connecting wires are there. There is a
Yes,
resistance
sir.
box or a variable resistance. But if you use this or this, it will do the work. A switch, a battery. Can you see? Basically, I'll create a circuit like this. I'll not connect this variable resistance because rheostat and variable resistance does the same work. Okay, so I'll be just using one of them. How is the connection made? Can you see over here? This rheostat is in 10th grade also. You might have seen it looks something like this, right? Right around,
Yes, sir.
Yes.
and
Yes,
basically
sir.
you have connected it across a variable battery. This is your variable battery. Suppose this is your positive. This is your then there is a switch, there is an ammeter, and there is a voltmeter connected over here. Can you see a voltmeter connected over here, guys? Everyone, is it clear?
Yes, sir.
So this is the variable battery. This is the battery. Can you see from the positive terminal we have connected? The order doesn't matter because all of them are in series, so it doesn't matter. Can you see over here when what will you do? You will first fix the value of resistance. Enough, guys. You'll move this. Can you see this thing, guys? Can you see where I'm pointing? This thing on the rheostat. Hello.
Yes, sir.
This thing on the rheostat can move, slide up and down on this rod. So basically, if you place it over here, so what will happen? Current will come from here and it will go here and only take this much length. So can you say this much length is excluded? So this is that much length excluded. Is this clear, guys?
Yes, sir.
So basically now what is happening? Current will come from here and it will go like here. It will go to the ammeter. Can you see the ammeter over here? And I think they have connected with this they have connected the resistance box in parallel. You see this voltmeter is connected in parallel. Can you see the one more thing? Can you see parallel connection, guys? The current is going like this. But can you see in parallel they have connected one voltmeter over here? Everyone, is it clear? So
How
basically
was it
what
parallel connection?
is a yes, this voltmeter is in parallel with this resistance box, not with this rheostat. Enough?
Okay.
Basically ultimately I told you to will use only one of these things and I will connect this thing in parallel with this. In this diagram they have created what? They have connected the voltmeter across in parallel with the resistance box, not the rheostat. But it does not does not matter. It is still fine. So now what is exactly this thing doing? See, basically from here a current will come over here. This current will go over here, come here. The current will never go in the voltmeter branch. It will come over here, and from here it will pass through this part of the resistance, and then it will go from here to here, pass through the ammeter, go over here when the switch is closed, come over here, and will reach the same. This is how the current will flow. This ammeter will read basically the current which is flowing in the circuit, in the primary circuit, and what will the voltmeter measure? The voltmeter will measure the potential difference across the rheostat or the variable resistance. Okay. So once we have fixed the value of resistance, what do? We increase the voltage. We keep on increasing the voltage, so we measure. This thing also increases. When this thing increases, can you see all of the potential of the battery will be across the resistor? Because there is only one element in the circuit, right? So all of the voltage which is there produced by the battery will be across the resistance. So what will happen? When you increase the voltage, this voltmeter reading will also increase and this ammeter will also increase. Is this clear? And when we have plotted a graph between this particular thing, and we plot a graph between V and bhai band kar dena, bhai band kar dena. V and I, so we'll get a straight line. Okay, is this clear, guys? So basically from here Ohm said that V and I are directly proportional. Okay, and he gave his law V equals to IR. So basically R will be equals to V by I. So the slope. Do you remember this thing, guys? Can you see this line V equals to IR is basically Y equals to MX? This is on the Y axis, this is on the X axis, and this is M. So Y equals to MX. And what is M? M is the slope. X is the one which we have put on the X axis. Is this clear, guys?
Yes.
So note this particular thing. Slope of VI graph with current axis gives us the resistance. Is clear?
So when we say VI graph, V will be the x-axis.
V will be on the Y axis. V will be
Okay,
on
and
the
I
Y
will
axis.
be in the x-axis.
Yes, V will be on the Y axis and I will be on the X axis. With the current axis, I think.
Okay.
Slope of this graph with the current axis, this angle, slope is basically given by tan of this angle, if you remember. Okay, so more the angle, more will be the slope. The slope of VI graph with current axis gives us the resistance. Is this clear? Okay. Acha, so if I have a question, acha, tell me this particular thing, guys. Now what can I do? I'll fix the resistance over somewhere else and repeat the whole experiment. Will I get the same graph? Or will I get some different graph? If I set the resistance over
The
somewhere else,
slope will change, yeah.
yes, the slope will change. So basically, I'm drawing two different VI graphs, but in the same. One graph is like this, and the second graph is like this. This is R1, this is R2, this is 30 degree, and this is 45 degree. Can anyone give me a relation between R1 and R2? First of all, oral question. Tell me which is greater, R1 or R2? Which is greater, R1 is greater or R2 is greater?
R1.
R1 is greater because this line has a more slope. It is more
Yeah.
straight, right? So hence, first of all, the basic oral relation R1 is greater than R2. Can you see? R1 will be basically tan of
45.
45 and R2 will be equal to tan of 30.
30.
So basically this is 1 by root 3 ohms plus 1 ohm. What is the relationship between R1 and R2? R2 is equal to R1. Is this clear, guys?
Yes, sir.
So,
Chalo. Do some more questions. A copper coil has a resistance of 20 ohms at 0 degrees Celsius and a resistance of 26.4 ohms at 80 degrees Celsius. Find do this. सात्विक here. क्या हुआ सात्विक तेरा स्कूल का प्रोग्राम खत्म?
Yes, sir.
What kind of what was it?
It was like a competition, and yeah.
क्या MUN?
No, not everyone. It's like we have to make a project and display to the judges.
How was it?
It was okay.
It was okay. मतलब कोई और जीत गया ऐसा?
Yeah,
What did they make?
I don't know. It was not like a price or anything. They didn't tell like what is the price.
Okay. So guys, see in the question what is given to you. At 20 degrees Celsius, sorry, at 0 degrees Celsius, the T naught is equal to 0 degrees Celsius and T dash is how much?
80,
R naught is how much?
20 ohm,
And R dash is how much?
26.4.
So, sir, you gave a relationship between resistivity. You didn't give a relation between the resistance. Can you see? If we don't assume any thermal expansion, so the same relation which we wrote for resistivity,
Mm.
they will be applied for. So you can write note where we wrote the formula. The same relation can be applied for resistance.
Resistance.
In fact, in place of rho, you'll write R. So here R dash is equals to R naught, which is 1 plus alpha R delta T. And from here, can you see R dash will be equals to, everything is given now. Will you be able to solve it?
Yes, sir.
Okay, so I'm leaving the solving part on to you people. When you solve it, alpha R will be 4 into 10 to the power minus 3 volt. Is it clear?
Can I please scroll
Yes.
a little bit?
Can you please scroll up? No, scroll करके.
Thank you, sir.
No problem. Next question. Okay, remember in current electricity we need to do capacitive circuits as well. Kirchhoff, when we'll discuss Kirchhoff, we have to do pure capacitive, pure resistive, as well as one which will contain resistance and capacitor both. So those type of circuits in which resistance and capacitors are both present are called as RC circuits. We'll do those as well. And the next question, I'm giving two questions for homework, guys. From now on, your homework questions will be way more. अभी तक मैंने homework किया नहीं ज़्यादा. Now the homework will become too much. Is this clear? So basically, from the given data, try to see what is given to you and how will you solve it. The final answer to this problem would be 50203.
Can you go up 1 minute?
Yeah, sure.
Okay, sir, done.
Next question.
Sir,
Yes, tell me.
are you writing something?
Yes, I am writing something. Are you not able to see it?
No, sir, it's stuck.
Can you see it now?
No, sir, I'll try leaving the meeting and joining again.
Everyone else can see me writing?
Sir.
Okay. I thought if it is like if everyone is not able to see, then see with my PC. These are your 2 questions for homework. I think हो जाएगा. Questions will be done, right? It is clear, guys?
Are you writing anything?
Abhi, I'm not writing anything. I have just the questions on the screen. Done? Everyone wrote the question, right?
Yes, sir.
Okay. What happened? Lishma, anything happened?
Say what will be the answer, so we can check with that.
Answer will be 2 into 10 to the power 19 electrons per second. Okay? Okay, guys?
Yes, sir.
See, that's the plus point of having notes. I can give you homework questions now. Earlier I didn't have any notes, so it was like homework questions. I didn't have anything to do for homework questions. Now I have something. Anyway, next heading. Guys, write down the new heading. Electromotive forces. EMF. Okay? Please remember this electromotive force from the name itself, it's like it's a force which tries to move an electron. Yes or no? But please remember from the name, don't go on the name. It's not a force. First thing, it is not a force. It's basically a voltage or potential difference across a device when no current flows through it. We'll come back to this definition a little bit later. First of all devices which can supply electrical energy in form of current flowing in the circuits are basically called as EMF producing devices. to electrical energy. So always remember, in any EMF producing device there will be always some kind of energy which will be converted to electrical energy, na? And by electrical energy I mean to say a potential difference across its end. Okay, whenever I'll connect it across a circuit, a current will start flowing. Example के रूप में if I give you, there is a battery, a cell or a battery. Basically what happens in the case of a cell or a battery, it converts chemical energy inside it to the electrical energy. Yes or no? Ultimately what happens over here, chemical energy gets converted to heat, heat gets converted to some work, work gets converted to some form of mechanical energy, and work, or you can say that work is mechanical energy, and mechanical energy is converted to electrical energy. The whole process takes place inside, but in short you can directly write chemical to electrical. Is this clear? Because these type of questions is generally asked, what is the energy conversion in this following, and I have seen these type of questions, that's why I'm writing on this. Generator, nuclear reactor. Sir, कैसी बात कर रहे हो? Can you convert, can you connect a nuclear reactor to a normal electric circuit? No. The one which you are getting inside your home, it's a big, complicated electric circuit only. And to power that circuit, we use bigger EMF sources. Is this clear? So basically, this will transform from mechanical energy to electrical energy. Now the heat produced due to nuclear reaction will be converted to mechanical energy, and then that mechanical energy will be converted to electrical energy. Is this clear, guys? Now let's come back to the definition part. Once you are done noting down this thing, just tell me. Then we'll come back to the definition part. Guys, whenever you're done, now basically suppose, guys, if you have a battery, when you have an ideal battery, you understand there is something called as ideal battery and a real battery. When you have an ideal battery, and whether if there is a current flowing through it, or current flowing into it, or no current is flowing through it, right? So can you see, guys, in this case, if whether there is a current present or current not present, in all these cases, if we try to measure the potential difference across this battery, so what we will get, whatever reading this potential will get, this will be your EMF. In case of ideal batteries only, right? So whatever potential difference which we will get, it will be termed as what? The EMF of the battery. Is this clear, guys? The definition part. Abhi definition I have not discussed parallel. But for a real battery.
So could you repeat the case of ideal battery?
Ideal battery mein one, in the first case is when current is supplied by this battery, current is supplied to this battery, and no current is supplied. Okay?
Okay.
Current supplied by the battery to the battery, no current supply. So in every other cases, whatever the EMF, whatever will be the potential difference across the terminals of this battery, that will be termed as the EMF of this battery. But generally, ideal things do not exist. Only real thing exists, right? So
So if it
basically,
was an ideal battery, the potential difference would never change.
no. If it will be
Okay.
a real battery is something which has certain internal resistance. We'll see exactly what is an internal resistance. So I is over here, and if you connect the V over here, then please remember, in this case, the potential difference across the terminals of the battery V will be less than E. Here it comes less than E. Here in this case, what happens? If this is a real battery, E comma R, and current is supplied to this battery, then the potential difference across this battery is basically greater than E. We'll prove this thing. We'll write an expression for these terms. But here, when a real battery, there is no current supplied to this battery. Again, when you try to measure the potential difference, in this case, only in this case, V is equal to. Okay, so can you see in this case, when no current is supplied for both ideal as well as real battery, the potential difference across its end was how much? Equal to the EMF, right? So basically, can you see the definition it came from here? It's basically a voltage or potential difference across an EMF producing device when no current flows through. Is this clear? When no current flows through it, or you can define it in this way. This is the EMF is defined as the open circuit potential difference across any EMF producing. Is this clear, guys?
So,
Yes, tell me. Done? EMF done? Everyone clear about EMF? Can you see in both of the cases, in this case also as well as this case also, V was equals to E when no current was flowing through the battery. Even if the battery is real or ideal, doesn't matter. If no current is there, then the potential difference across its end will be termed as what? The EMF. Is this clear? Is this clear, guys? So, next heading, once you're done with this thing, next heading is the internal resistance of a battery. Done? Everyone done? Next heading, internal resistance of a battery. What is internal resistance of a battery? Suppose if I have a battery, ज़्यादा बड़ा बन गया. These are the two electrodes of a battery. Have you started a chapter electrochemistry in school or in coaching?
Yes, sir, we did
We
this.
will finish
So
it.
you know
Yeah.
exactly what is a cell.
Yeah.
Cell सबको पता है, right?
Yes.
So basically, this is a cell. These are the two electrodes. This is positive electrode, negative. What is the positive electrode called as? What is the positive electrode called as?
Anode.
Yeah.
Anode.
And what is the negative electrode?
Cathode.
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 See, there is a trick to remember cathode and canode. Cathode and anode. So, see, cations are generally positive. We know this thing, right?
Yeah.
है ना? So always remember cations are positive, anions are negative. This you need to remember for this. Always remember cations are attracted towards cathode and anions are attracted towards.
Anode.
So hence, what is the charge on cathode
Negative.
and what is the
Negative.
charge on cathode?
Positive.
Remember this trick, है ना? Because this is how I have remembered it. Otherwise, I always get confused in anode cathode only. So, anyways, there is an electrolytic solution which is there inside this particular thing. Now, what does this electrolytic solution consist of? It comprises of ions, both
Yeah.
positive ions as well as negative ions, right?
Yes, sir.
So basically, what will happen if this positive and negative ions will be there? What will happen if current will be passed through this battery? What will happen? Those electrons, they will collide with these ions, right? The electrons collide with these ions, right? Whenever this thing is connected to
Yes.
a circuit, then what will happen? Electrons will start transferring, right? So the electrons will go from the negative terminal like this. Yes or no?
Yes, sir.
The electron will come on the positive terminal like this. They will go into the solution, and then this electron will travel from here to here, right? So
Yeah.
during their
Yes.
travel inside the cell, will they be subjected to collisions with the different ions?
Yes.
The electrons inside the battery, when electron travels inside the battery, then they are subjected to collision because of the ions or chemical present inside the battery. Yes or no?
Yes, sir.
Basically, this resistance offered to the flow of current or the flow of electrons due to chemical composition of the battery is termed as is termed as
Internal
internal
resistance of.
resistance. Is this clear, guys? So basically, any real battery will be the one which has internal resistance. For an ideal battery, we consider the internal resistance to be
0.
0. For ideal battery, अच्छा, denoted by, what is this internal resistance is denoted by? It is denoted by smaller. Please remember, EMF is denoted by this symbol epsilon, but not the small one, the capital one. So remember the small epsilon you used already in electrostatics. The big epsilon you use it for EMF. Hello? समझ में आया, guys?
Yes.
You already used the small epsilon which you drew like this. Which you drew something like this, right? You drew the small epsilon like this, right?
Yes, sir.
1 by 4 pi epsilon naught. That was where you use the small epsilon. So big epsilon is used over for determining limit. Please remember, for ideal battery, the internal resistance is Is this clear? Just for example, if I have a real battery, the real battery, how will you give a real battery? Real battery will be shown, for example, let's say this battery has 20 volts, and with a comma, you'll write whatever is the internal resistance, let's say 1 ohm. So basically, how will you treat this internal resistance in electric circuit analysis? It basically will consider that this 1 ohm is in series with the battery. So now this real battery becomes an ideal battery with a with this resistance in series. Can you see this thing, guys? Hello. This is how you deal with it in electrical circuits. It's one and the same thing only, but basically what do? You just write it separate. Okay, guys. So you can write this particular thing somewhere. Guys, are you writing along with me? It's not necessary only battery. Internal resistance of any other circuit also, any other device also. Always remember, we will take the internal resistance always in series with that device. Is this clear?
Yes, sir.
Chalo, with this thing. Now, acha, one formula you all know, resistance is basically R equals to rho L by N. Everyone remembers that formula, right?
Yes, sir.
Okay.
Yes.
There is something which is called as grouping of resistors, which you people have been already been doing in 10th grade, but I think your teacher never told you what exactly you are doing. Whenever you remember, you were combining whatever, suppose if there was a circuit, this was there, then these two were there, and this something like this, whatever it was, you know, whatever be the connection, basically what did you do? The whole thing you considered as equivalent, right? Or basically you told it as the single resistor net resistance, if you remember. So guys, see, the question is about what is grouping exactly? If you have any circuit which is given to you, can you see a complicated circuit of including various number of circuit resistors are there, which are
Yeah.
in series or which are in parallel, right?
Mm.
Whatever combination it may be. So basically what you basically did what? You took first these two in parallel, then the net combination of this is in parallel, in series with R2, and then R5, R6 is in series, then there's this in parallel with this, and then the whole thing in series with this. Yes or no? You already did this type of question in 10th grade. And ultimately the final goal was to find out the net resistance, if you remember. So what do you mean by grouping of resistors? That if the whole combination of these resistors when connected across a battery of EMF E, now will not be using V, will be using E every time. So EMF E, then let's say it produces a current I. So in this case, when all these resistance are replaced by a single resistor of net resistance on it, the same current should be produced. Then we say we have grouped these resistors to a single resistor on it. Is it clear? This thing is basically called as the grouping of resistors. Here, basically, what will you do? Whatever will be the current, you will say I is basically E by R net according to Ohm's law. And what is I? I is the current coming out of the battery. Yes or no? Yes or no, guys? Any doubt?
Yes, sir.
Okay. So basically, this is called as grouping. Remember. Grouping is there. Now we have two different types of grouping. One is series combination and one is parallel combination. Everyone knows series and parallel combination.
Yes, sir.
So the first type is basically series combination. What is series combination? Everyone is familiar with series combination, right? Suppose,
The resistors are connected end to end.
very good. Whenever two or more devices or resistors, what we want to say, are connected end to end. With each other, as well as the battery. Then it's a then this is called as what? The series combination. Suppose if I have a resistor over here, resistor over here, resistor over here, and I connect this whole thing to a battery of EMF E plus minus current flowing through its I. This is R1, this is R2, this is R3. And what do I need to do? I need to convert this to I need to group these two RS, the net combination of the series of these two resistors. I think you have already done the derivations of these three, right? Yes or no? Can you see
Yes, sir.
series? There is only one branch here. Can you see? Series combination. The current flowing through all the devices across that branch is always the same. So can you see, guys, here this is the potential producing device. So it can you see only one branch is there, and that branch is forming a loop, right? Can you see only one wire? Can you see a single wire? This is a single wire through which resistance R1, R2, and R3 are connected, and this wire is connected again back to the battery. So here in this example, R1, R2, R3, E, and this battery of EMF, every one is parallel with each other. Guys, here
Yes, sir.
R1, R2, and R3 are in series with each other as well as with this battery. Okay?
Sir,
Yes, tell me.
so here why are we taking the electromotive force? Because current is flowing through it, yeah.
Yes, current. This device is producing the current. Resistance that are not capable of producing any current. है ना?
Okay, okay. Yeah, okay, I understood.
So, so now this please note in series combination the current through every device which is connected through that branch is always same, whereas the potential difference will the potential difference across various elements is different. Is this clear? Potential difference is this clear, guys? So remember this note, very important. So basically here what is the potential difference creating device over here? Can you see through the whole circuit the potential difference was E? Right? So we are talking only about from this point to this point. We are combining only these all, no? Can you see we are combining across points A and B. So we are grouping R1, R2 and R3 together like this to RS. Basically, are you getting my point, guys? So what was the potential difference across points A and B? It was E. Here also it is E. But here in this case, what this potential difference will do, it will divide itself in three parts. It will be V1 across this one, V2 across this thing, and V3 across this one. So can you see from here, E is equals to V1 plus V2 plus V3 because it was dividing, right? Yes or no, guys? So can I write E is basically, what is the current through resistor 1? What is the current through this resistor?
I
What is the
I.
current through this resistor?
I.
And what is the current through this resistor?
I.
So basically I into R1 plus I into R2 plus I into R3. And can you see from here? Here also it is I into RS. So E is basically I into RS. So this is one of the derivations in your school as well.
What's the actual reason for why this happens? This was a similar derivation we did in
10th grade.
class 10 as
Yeah.
well. Yes.
In what?
But we never learned the reason why potential.
It's because the conservation of charge. मुझे एक बात बता, कभी तेरे को एक रास्ता दिया है ना? तू charge है suppose. If you are a charge and you have only one way to go,
Okay.
तो तू आगे बढ़ना ही पसंद करेगा ना, no matter whether that path is hard or not.
Yeah.
So just the same thing goes for charge as well. आगे उसको पता है कि इस रेजिस्टेंस के बाद वो रेजिस्टेंस है, उस रेजिस्टेंस के बाद वो रेजिस्टेंस है, but still it will move in the same path because it doesn't have any choice.
Mm.
So it's like the charge is same through both of them, and that charge is passing through all of the resistance in the same time. That's why we consider this as one. Hello, that's why the current is same.
Okay. Okay. Got it, sir.
So anyways, it's in accordance with the conservation of charge. So is this clear, guys? So basically, can you see whenever there is a series combination, you just add up all the resistances? Yes or no?
Yes.
What did you do?
Yes.
What did you do if the capacitances were there?
We take the sum of the
They are
reciprocals.
reciprocal. So 1 by CS is equals to 1 by C1 plus 1 by C2 plus 1 by C3, right? Is this clear, guys? Is this clear?
Yes.
No. Now the trick to divide potential. There is one conventional method which you can follow. Conventional method is basically what? What is the conventional method to find out anything? The conventional method is to first find out what is R net. The second is find out the current coming out of the battery. And then use current division. So basically, we have two different tricks. This one is easier. This one is called as voltage division. Okay? So, we'll discuss them later on. So, trick to divide potential directly. Suppose there are three resistors. And what is the potential difference across them? What is the potential difference across them? E, right? All three of them combined. Yes or no? Because they were connected across a battery of this thing. Yes or no, guys?
Yes, sir.
Yes.
So these three resistors were connected across this battery. That's why the combination, the potential difference across the combination of these three resistors is basically E. So the total is E. Now, what is the current? What is the net resistance? Is IR1 plus R2 plus R3. The current through the battery will be E upon R1 plus R2 plus R3. And can you see V1 is basically I into R1, right? You remember we wrote V is basically I into R1. V2 is basically I into R2. V3 is I into R3. So V1 is basically R1. So can you see, guys? Whichever resistor you want to calculate the resistance, calculate the potential difference about. Basically, what will you do? You will just take that resistance in numerator. You will sum all the resistances, and basically, what you'll do, you'll just multiply by. Question. Suppose there is a resistance of 2 ohm, 3 ohm, and 5 ohm. And if someone says that this is connected across a 20 volt battery, then what is the potential difference across this 5 ohm? So what will you do? Will you be doing the whole conventional method, or will you be just directly applying the trick? And it does not matter whether 3 are there or 4 are there or many are there. It can be applied to any number. This trick can be applied to any number. Any number of resistors in series with each other. Please remember, it should be only this case only, na? Only this should be the case when there is R1, R2, R3 in series. So how will you do it? What will be the potential difference across 5 ohm? It will be 5 divided by 10 multiplied by 20, which is 10. What is the potential difference across 3 ohm? 6 divided by 10, or sorry, 3 divided by 10 multiplied by 12, 6 volt. Potential difference across 2 volts will be 2 divided by 10 into 20. Is this clear, guys? Direct. Is this trick clear?
Yes,
Yes.
sir.
This trick is called as voltage division trick. Na? So use this, and once you found out the voltage, you can find out the current as well. Na? So can you see what is the current across this? 10 divided by what is the resistance? What is the resistance? 10 divided by 5. 10 divided by 5 is 2 ampere. 6 divided by 3 is 2 ampere. 4 divided by 2 is 2 ampere. So can you see, you can find out the current as well. Okay. Is this clear, guys? Any doubt? Is this clear, guys? Any doubt?
No, sir.
No, sir.
Okay. Special cases for n different resistors. In the next class, we'll discuss parallel combination, and then we'll combine both of them. We will not be doing direct questions based on just series or just parallel. We'll just be doing the combination. And I'll be teaching you various different methods and whatever tricks I know for current electricity. Okay? So that at least circuit solving part will be easy for you. And once you know the circuits, EMF, magnetic effect of electric current, these all become easier. So for all different series combination will be R1 plus R2 plus dot n. Yes. Second. For n equal resistors in series. If every resistor is equal, that implies R1 is equals to R2 is equals to Rn, which is equals to R. Basically, what will you do? You will add all of them, right? So R plus R plus R plus R. How many times? N times, right?
N times.
Okay. Third trick for voltage division, I told you already. I told you this trick for voltage division, right? This is very important. And the fourth is voltage division for equal resistors. Suppose, guys, I have this example. This is guys, can you see two different circuits? Hello guys, can you see two different circuits?
Yes, sir.
So basically, if this thing, what shall be the potential difference across 100 ohm resistor and 2 ohm resistor in both the cases? Direct divide करना है. You don't need to use. You can use the conventional method if you want, but that's why I'm doing this as it is over here. Can you see, guys? Here in this case, can you see? Do you remember this thing? V1 equals to V2 equals to this thing. By Ohm's law, if I have by V equals to IR, since I is constant, then can I say V is directly proportional to R? If you remember grade 5 or 4, this is direct proportional relation. Direct proportionality, है ना? Potential difference in series is divided according to direct proportionality. Whenever it is direct proportionality, it's very easy to divide. So can you see according to the direct proportionality or ratio? What was the ratio of this thing, guys? Hello?
2:3:5.
So 2:3:5, right? Everyone? Is the ratio clear?
Yes.
Yes, sir.
What is 2 plus 3 plus 5?
10.
10 pieces. Okay. So divide 20 in 10 pieces.
2.
So 2 volt. Can you see 2 volt? So basically give how many pieces should be given to 2 ohm? Since it is direct proportionality. So 2 ohm will have 2 pieces, 3 ohm will have 3 pieces, and 5 ohm will have 5 pieces. Right? So
Yes.
1 piece of 2 volt, 2 pieces, 4 volt. 1 piece to 2 volt, 3 pieces, 6 volt, and 1 piece of 2 volt, 5 pieces, hence
10 volt.
And also basically direct proportionality, this you already have studied in grade 4 to 5th, proportionality, ratio proportion. And here in this case, since the resistances are equal, so potential difference will divide equally. Can you see, guys, both this 2 ohm are in series? How? Can you see the current? This current, this current, this current, the same current is entering the 2 ohm. So hence they are in series connection. Please remember this thing which I do, it's called as branch manipulation, which you will be learning very soon. I'll be teaching you SS method also. No? So the resistance are equal, so potential difference will divide equally. So across this 10 volt, what should be the ratio proportion? 1:1, right?
Yes, sir.
How many pieces? 2 pieces. So 10 volt, 2 pieces, 1 piece, 5 volt. So basically across this also is 5 volt and across this also is 5 volt. The same thing goes for this as well. Basically here also. So the resistance are equal, the potential difference will divide. Is this clear? So this thing series
Yes.
combination is over. In the next class, I'll start with parallel combination. The throat is, I don't know what is. So anyways, We'll see you again in the next class, guys. Thank you very much.
Thank you, sir.
Sure.
Thank you, sir.
Thank you, sir.
Okay.
Thank you.